Hey, Ricardo here, ready to start the fourth program of the ROS Mastering Live Show. I'm very excited because we are already on the fourth program. So that's great. And today we are going to do a shorter program because of the lack of time that we have today. But don't worry, we are going to resolve a very interesting question. That's a question made by Wayne from Taiwan. And his question is, hi, developers. I'd like to know how to create a gazebo simulation environment with April tags in it, so April tags in it, and use it to do some simple navigation. For example, control a car to the positions of each April tag within a given order. Thank you very much and cheers. Great. Good question, Wayne, good question. And maybe some of you are asking, wait, what's that about April tags? What is this? So let me show you what I'm talking about when I talk about April tags. So let me share the screen. And here I have a video that you can see of a series of April tags. The April tags are the tags that you can see on the box or on the table. That is this kind of mosaic composed of black and white dots. You see, those patterns are very easy to be identified by a computer program, by a vision algorithm, and they are used in order to create references for robots. In this case, they are used to to calculate the position and the orientation of the box on the table, etc., etc. We can use this for controlling the robot, or maybe we can put those April tags on the door of a room, and then the robot, when passes through that door, then we'll see the April tag and identify the door, which one it is, just by looking at the April tag. So we are going to use this April tags for commanding navigation in a kind of parrot control. You know what I mean by a parrot control? I mean, when I say a parrot control, it means like when you have carrot. It's carrot control. So carrot is when you have a stick, and then on the end of the stick there is a carrot, and then you put it on the front of the donkey, and then you have then the donkey will try to catch that carrot, and then you can command, by doing this, moving the stick, you can command the donkey to go from one place to another. So we are going to construct this simple controller by using an April tag. So the robot will detect the April tag and then try to go into the direction where the April tag is there. And we can move it, and then the robot should follow. So that's what we are going to try to do, okay, today. So let me show you one thing that is a small modification. Just instead of using April tags, we are going to use another type of tags that is called AR tags. And the reason of this is because really I don't know what is the difference between those two. And in the case of the AR tags, we already have some control software made in ROS in this package that it's called the AR Track Alvar. So this is the package that allows you to create April tags like this. So if you download this and follow the instructions, very, very simple instructions, this for installation, you will be able to create your own AR tags. And then once you do this, you will be able to use also the software that is included in this package in order to identify where are located the AR tags. And you can use the information that is produced in a topic. Let me show you the topics is here. In this AR pose market topic, it contains a list of the poses of all the AR tags with respect to the output frame. So if the output frame is the camera that we have in our robot, then we know the position of the April tag, and from that information we can decide the direction and the movement command for the robot, okay, in order to go in that direction. Great. So let's go. So we are going to use the AR tag. Then for that, we are going to use in order to show you how to do this, we are going to use, of course, as always, the ROS Development Studio that you can access at rds.theconstructsim.com. So you can create a free account and start doing the same things that I am doing here, okay? So just feel free to use it or reproduce it in your own computer, local computers. The only thing that you need is to have the gazebo, ROS, and the AR track packages installed. Great. So we have that already here installed. So we are ready to start. So I have started. I have created a project. It's a project that I call Greenbot MegaFest. Whatever. Don't ask because of why we have this very funny name here, but that's the name. And then the first thing that we need to do is to create an AR tag for the simulation, so we can launch in simulation. Okay, so I have already done this because today we don't have the time to show all the steps, but don't worry because you can see one of our videos that is here. I will include all this information on the notes of the video of the webinar of this session, live session. And in this video, you have the information about how to create the April tags for gazebo and how by using the Blender here, how you can use this. First, you create the AR tag here. Let me show you. Here you use the information here to create your AR tag. Then you put into this shape that we change later, a little bit later. We change this, and then we show you how to put the April tag on this shape. And then finally, on the last part of this video, you are going to see how to include it into the gazebo simulation and spawn it here. Okay, so this is the first video, and I'm not going to show you now because of our lack of time of today. But you can just see this video is 70 minutes, step by step, very, very clear. And also you can see how the April tag is detected here by the end of the video. Then this is one thing that we need. So we need to include an AR tag inside the simulation. Okay, so let's do that. So I already have it, then we don't have to do it, but let's use it on a simulation. And as for the simulations, we can create our own simulations here in ROS Development Studio, but today I'm going to go fast and simple, and I'm going to use one of the simulations that is here, that it's already in this list that you can just press and launch. And today we are going to use the IVO simulation. So I'm going to press this on IVO, and the IVO simulation is going to start and in a few seconds. So we'll see here the IVO, and we are going to use the IVO to move into the direction of the AR tag. And the movement is going to be a little bit artificial by using a common belt topic, like if the IVO robot were a wheeled robot, a differential robot, okay? It's not going to move the leg like this. You will see this about the legs in a few weeks because we are preparing very special videos and code in order to move IVO, walking and moving all the legs, doing walking, real walking, okay? But it's not for today. So today we have this simulation, and here we should have IVO around here. Here it is. Okay, so this is the simulation that we are going to use, and we are going to use the camera that IVO has here. And as this, let me launch here the camera viewer, and I'm going to put it here and select the camera that he has on the head, that is called the head camera. So we should see what IVO is seeing. Okay, yes, I know that we should have this system better. So to remove this, we'll improve in the next week. Don't worry. So that's what IVO is watching, you see, in front of him. Great. Now, let's go and let's spawn one of the tags here in the simulation of IBO. For that, I have created some packages that already do that. And those packages are the ones that you can see here on this video, okay? It's exactly the same. I'm just going to the final of the video to spawn the tag here. And I'm going to do that. So for that, I'm going to open a shell. And we have to do a spawn that is in a package that we have created there. So it's called ROS launch green description spawn. Okay, so this is the command. This is the command, and let me launch it. And then some April tag will appear here. There it is. You can see the April tag that is there. Of course, it's out of the sight of the eyeball. Well, it's here, just in the corner. You see that it appears there on the corner, but it's too far away. So don't worry, this is not a problem. We can either approach the tag or the eyeball robot to the tag. So let's do this, for example. So I'm going to approach it and then rotate it. And then let's see. Okay, there it is. So the tag is there and the robot should be able to see it. I don't know if it is too far. Maybe sometimes it's difficult for the system because you can see it's difficult to identify something on that image there. So, but don't worry. So we are going to experiment. Maybe I will move it a little bit more. Okay, so there it is. So far, so good. So what do we have now? We have spawned this tag here, and you can see, and then we have the eyeball robot ready to detect this. So now the next thing that we are going to do is to use the tracker. Is the software provided by this package, the AR track alvar, that looks into the camera information and then tries to detect the patterns of the tags. And when it detects one of those patterns, then it publishes in this topic, AR pose, the pose of that tag that has been detected. Tag or tags actually is a list of tags. In our case, we only have one, so it's going to be only one. Yeah. So how do we start this program and how do we do that? This is the subject of a second video that we also have created in this series. I will put also the link to this video in the notes of the webinar. And you can see here how you have to configure everything in order to be able to detect the tags with this simple robot that is also included in RDS. And then it explains how to do all the steps that I have already done and how to visualize on Orbis. Yes, you see here that is you can see here in pink, there is a marker that is signaling in reference to the camera in which position has been detected the attack. And that's what we are going to do right now, okay? So for further instructions, just go to this video and watch it. You're going to learn a lot in that case. But now I think it's better if we move to the whole application. So for that, I have prepared already everything by following the steps of this video. And that's what I'm going to do. So I'm going to launch the system that detects the tag. It's basically the package with the proper configuration of the AR track alvar package. So for that, I have to launch this command. This AR track greenbot, and then our proper launch. This launch, you should see how to complete this launch in this second video that I mentioned, okay, the part 2. Great, so I'm going to launch it. And then the system will start detecting the tags or trying to detect the tags. And how do we know that? How do we know that it's tracking? Well, the system looks like everything is working. Now, let's go to the RBIS and see if it's detecting something or not. For that, let me open here the graphical tool. Wait, sorry, I need another shell to launch first the RBIS. So I'm going to launch RBIS. And then I'm going to wait. Then, okay, I don't know what happened. Then I'm going to launch the graphical tools, and the RBIS should appear here. Great, we got it. Now, let me put it on top. And let me also load a previous configuration that I have created so we can go straight to the point. Great, here we are. This is the TF of IVO, and this is the tail, this is the body, and then here you can see the head with the camera in there. Basically, this is the structure of the robot. Okay, but it looks like it's not seeing the tag because there is no tag, the marker indicating in front of it. Oh, sorry. Yes, it is, but it's very far. Okay, yeah. So great. So that is the program that is detecting the tag. So let me show you one thing. If I move, let me just resize this to a proper size so we can use all the space. So the robot, the tag is here. That's the camera, what the camera is watching. And this is what the program is seeing and detecting. So I'm going to move the tag, and you will see in RBIS how the detection changes. So if we have it here, I'm going to move it to the left-hand side of the robot. And now we should see how the detection has changed. You have seen it, yes? So I'm going to approach it also. Wait, I have to move this, yeah. So I'm going to approach it. And now the detection should change to a closer, when you select this in Gazebo, the actual position is not set until you remove the movement arrows by pressing here. So now you should see, yes, so you have seen the change in the position, okay? So I'm going to also to move to another direction. Then it should move, yes. Okay, so far so good. So we have here a system that uses the camera of the robot and the AR track alvar packages in order to make the robot detect those tags. Now, final step is to move the robot into the direction of the tag. That's a very simple planner that we are going to do, very, very simple one. You can modify that, you can include into different other planners and integrate it. So that would be nice to see in case that you try it, okay? We are going to show just a very simple controller for that. And first, let me show you where in the topic of ROS is the detection of this is being published. So let's go to one of the shells. Okay, this is used already. Which others do we have? Okay, this one and this one and this one. Okay, this is ready. So this is the topic where the markers are published. And as you can see by the message that is being published, it contains all the information about the different markers that have been detected. Here, it indicates the frame from which the position is detected. And here, based on this frame, here you get the position and the orientation of the marker. So that's what it's been published. And now what I have done then for the proper controller for navigation, well, very simple. So I have here a problem. Okay, so I'm trying to resize this, but yeah. So here I have created a package, Carrot Navigation, very simple. And this Carrot Navigation, I'm going to open it. It's just a Python program that the only thing that it does is first to subscribe to the AR post marker, that topic that you have seen. Then every time that we got a new detection, then this detection, it's a store the position, or the position of the store of the marker is stored here in the carrot variable. Okay, if there is none, then just a 0 is stored there. Remember that the structure of the message. So here we have the message. You remember, then we have all that structure, and then at the end we have the position that it's a point that contains the 3 coordinates, and that's what we are storing here. It's just that part here of the whole message. So we know that. Then this is for the subscriber, and then afterwards we have a common bell topic in IVO that allow us to move the robot using a twist message. So you can use the same procedure for a wheel robot, for example. And in the future, we are going to do the same, but instead of common bell, it's going to be a walking system. So they will adapt the robot legs and walk like a real dog. Then. But for now, it's only working as a static element that moves like a differential drive. Okay, so we publish in this a differential drive velocity, a twist, and that's it. And this twist is called a speed, and it's calculated from the distance in the different axes to the tag that has been detected. Okay, so let me see if we can come here closer to the here it is. So I wanted to see the frame. Let me eliminate all the frames here. And sorry, no, it's not that one here. So I'm going to put only the camera one, the camera link. Okay, you can see on the camera link, I'm doing on this controller, I'm doing an approximation. And this camera link, it has the red, that is the x-axis on this direction, and then the y-axis on that other direction. So I am making the assumption in order to make this faster. So I just made this approximation that this is completely flat, but that's not the case. So we have a small, as you can see here, we have a small tilt on the axis. So it's not completely parallel to the ground, but I am assuming that it is, okay? And that the green axis is the one on the, is parallel to the ground, and it goes into direction of the front of the robot. And then the red axis, that is the x-axis, goes in the direction of the right of the robot. Okay, so based on that, I'm approximating this just to simplify. You can do many calculations. Well, you can actually do a transform from the data from this point to the base link, etc., and then get the exact numbers. But this is not necessary, just to show you the procedure of creating the controller. Okay, so I'm assuming that, okay, that the green one is parallel to the ground and the red one is on the going on the x-axis on the right of the robot. Based on that, once we have a position of the object, we can calculate the linear speed of the robot, of course, in x-axis, because it's a differential drive and only has a use of an x, so only requires the x, like the value of the caret y, but with the minus signal, the minus signals. And I have divided into 10 in order to produce a very small value so we can see when the robot is moving, because otherwise the robot will move very fast. And then the same for the angular. That means the rotational value of the speed is based on how much on the x-axis the robot is moving. And also it's related with a minus signal. I have decreased by only divided by 2 because it's enough. So what we are doing is just detecting the marker. Then based on the position obtained, we compute some very simple linear and angular velocities, and then we publish on the Camembert speed. That's it. That's simple. So let's try and see what happens. Yeah. So this is the program, and it's I'm going to launch it. Okay. First, let me put all the interesting images. Let me see here. So yeah. Yes, and then the camera viewer also. Let's make it a little bit smaller. So we can see everything. And then this is where I'm going to launch a program. So I'm going to put it here and here. And this one, I'm going to hide it. And here we will see the simulation. So we can move the tags and make the robot move into one direction or another. Great, so far so good. So let's see with this setup how we are moving, so how the robot is moving. Okay, so for that, in order to launch that program is ROS run. It's called the carrot navigation and the carrot pi. That is the program that I just shown you. So I'm going to launch it, and then, so first detection is 0, says, okay, nothing. But then now it's detecting that, so it should start moving. Okay, there it is. There it goes. As you can see here, it's moving, and as the robot is moving, of course, the perspective of the tag is changing, and you can see how the vision is changing, and then, of course, the detection is also changing. So let's move a little bit further this. And let me, for example, move it a little bit backwards. So wait. So yeah, so it went out of the scene, I think, or is maybe it's around here. Yeah, yes, it's around there because it's been detected. So for sure that it's on the image. So I'm going to move it. Yeah, there it appears on one side, and then see if the robot turns into that direction. Still, so now it has been detected on the other side. Let me see. Yes, it's detected here, and now the robot is turning into that direction, as you can see. The marker is still detected there. Here it is, and the robot always tries to put the marker on the front. Okay, so that's it about using the AR tags and making the robot navigate. So that's the end. As I said, in the future videos, we are going to show you how to make the robot actually walk, because now it's a little bit, it's not so interesting just to simulate the movement like this. Okay, so far so good. Then any questions related to this problem? Show me your questions. So I see no questions. So I see a question by Sanyam that it's about the ROS Ambassadors program. And Sanyan, please be patient. We have a lot of work to do, and we just contact you on Monday. and we have many things to do. So don't worry, we are going to contact in a couple of days. Don't worry. So be patient about that. Any other questions? Is not, there is a question, you can post it there. So let's move to the next thing, that is about a tool that I would like to share with you. It is a very interesting tool made by one of our friends. It's Jose Maria from the University Juan Carlos I in Madrid. And it's a very interesting tool for all of you that are programming ROS. And because probably you require to use state machines for the control of your robots. But if you use Smash, the typical thing by ROS, to build your state machines, you have suffered how hard it is to build state machines and also to debug them and see what is happening. So what Jose Maria and his team have built, it's a thing that it's called the visual state. And the visual state is a system that allows you to graphically define your state machines and then check the current status in execution time. So let me share with you. This is I recommend you to watch this visual state example with an air drone, where the creators of the system have created this simple state machine where the robot is a drone to be controlled, and then it has to perform a square movement and then land in a proper place. And so by using their graphical interface, they can define the state machines, then generate the Python code that will control. And then once they have the simulation with the robot there, they launch the code of the simulation of the state machine. And then they can see in real time here how this is the visualizer, how the robot is executing on the different steps that of the state machine, and the robot is transitioning from one to another, so you can see in which state it is and which conditions are met. So now it just changed, etc., etc. So this is a useful tool for ROS programmers. And then I recommend you that in case that you need to create the state machines, use this because it's a lot simpler and faster. Anyway. So basically, that's it, the program for today. I would like to see if you have any question, and I'll be happy to answer now in some minutes. So let me see. Do you have any questions? Sanyan, he says he was worried about the deadline. Don't worry, Sanyan. And apologies, no necessary. It's okay, Sanyan. So don't worry, we are moving forward, okay? So just stay with us. Great. Any question? Any question? I see that today the people is a little bit less. Maybe it was clearer, the explanation, probably. Yes. So great. If there are no questions, then I will tell you that we are going to do another webinar. It's a webinar, okay, on next Tuesday. It's about how you can create a workshop, very simple, and how you can deliver this workshop in a very practical way. So making that the attendants to the workshop, they do practice what you are explaining at the same time. So this is a webinar that we are having next Tuesday. And of course, on next Wednesday, we'll have another live show, of course. And you can send us your questions through the website. You know, the link is beneath this video. You will find the link to ask us a question. And they should be questions for real problems. So if you are building this, you cannot do that, etc. So that's what we are interested in, more than just how can I publish in a topic? How can I do this? But something that is practical and that people can use in the real life. Especially you, that you have the problem, okay? And then Sanyam is asking how to execute the gazebo simulation offline. Okay, so how to execute a gazebo simulation offline? That's explained plainly in the gazebo website. So just go there and follow the steps. I mean, it's very, very simple. If what you mean is how you can execute the AIBO simulation offline, then that's a better question. And the answer to that is that you have first to download this simulation. And we have a public repo that contains all the simulations that we are producing there, and that you can download those simulations. So I'm going to put the address of this public repo beneath this video, then download the repo, and then just launch it like any other simulation. Usually all our simulations have a main.launch file. That's the one that you have to run in order to run the simulation. And that's it. I see that there are no more questions today, so let's finish here for today. And if you have more questions, go to the link beneath the video and send us your question, your practical question. We are eager to hear from you about that. And so that's it. Thank you very much, guys, and see you on the next live show that will be next Wednesday. And if you like our videos, please subscribe to our channel and press the bell so you will be notified every time that we publish a new video. We are actually publishing one new video every day, including the weekend. So don't miss any of those, and subscribe and press the bell to be notified. Cheers, mate. I will continue doing my training here. So I missed this. Yes. Let's go. Oh, let me just stop first. Yeah. Cheers.